Okay, so we've seen functions on their own, so f of x or g of x, but actually you can combine two of functions together, and that's actually known as composite functions, right? So let's say we wanted to get fg of x, which is a composite function. Well, firstly we apply the g of x first, and then put that into the function of f. So the way I like to remember it is whatever letter is closest to the x, that's the function we're applying first. Okay, so we apply the g first, worry about the f after. So let me try and illustrate this below. So let's say we had x and we're trying to get to fg of x. Okay, so that's our end goal. Well, what we want to do first is we want to apply the g first, like I said. So we'll apply the g, and so that gives us g of x. And then we want to apply the f. And that will get us to fg of x. And we can do that in one big step of fg. Okay? So we're given the functions f and g. F of x is 3x plus 2 and the function for g is x squared plus 4. We need to find the composite function fg of x. So remember what I said, we apply the g first and then we worry about the f afterwards. So we've got g as x squared plus 4, and now we have to apply that into the f. So in other words, wherever there's an x in the function of f, we replace it with the function we have for g. So part A, for f, g of x, we say that's 3, and replace that x with the function of g of x. So we've got x squared plus 4. And then we add the 2 at the end. So now if we expand that, we've got 3x squared. 3 times 4 is 12. Add the 2 is 14. Okay, so that's part A. As for part B, we now have to do it the other way around. So gf of x does not necessarily mean fg of x. So in this case, we apply the f first, which we've got as 3x plus 4, and then we apply that to the g. So wherever there's an x in g, we replace it with the function of f. So g is x squared plus 4, so we're going to replace that x squared with 3x plus 2, and because it's squared, we're going to square it. So it's, let's say, gf of x equals, and 3x plus 2 squared, and then we just add the 4 at the end that was already there. Right, so expanding that, so we got 3x times 3x, which is 9x squared. 3x times 2, 3x times 2, so that's plus 12x. And then we square the 2 at the end, which is 4, but then we've got to add on the 4 at the end here as well, so that's plus 8. Right, and that's part B. So part C is telling us to find the function of f squared of x. That's the same as saying f of x. Alright, so we're doing exactly the same thing, except we're taking its own function, 3x plus 2, and plugging it in to where this x is. So I'll say that for part C. F squared of x is 3, and wherever there's the x, we're plugging its own function back in, so we're saying 3x plus 2 and then we got the 2 at the end to add on. Right, so expanding that, we say 3 times 3x is 9x, 3 times 2 is 6, and then we've got the add the 2 at the end, so that's just plus 8. Now finally for part D, we need to find the values of b such that fg of b equals 62. Well, we worked out what fg of x is in part A, so that is 3x squared plus 14, but of course because the function x has been replaced by b, we need to write it in terms of b. So part D, we say fg of b is our function we wrote in part A, just replacing the x with b, so 3b squared, add 14, and in this question we're being told that equals 62, so we just say equals 62. Okay, now rearranging, we can minus 14 from both sides, so we're left with 3b squared equals 48. And then we divide by 3, so we're left with b squared equals 48 divided by 3, which is 16. And then we can square root both sides, so we're left with b equals, oops, sorry, my pen's just gone off a bit there, so b equals plus or minus 4. Okay, so I hope composite functions make a bit more sense to you now.